So, friends, this is Nutan. Welcome to our Mavericks channel. तो लास्ट वीडियो में हमने परम्यूटेशंस के एग्जांपल्स देखे थे। इवन परम्यूटेशन क्या होता है और परम्यूटेशन क्या होता है, उसके ऑर्डर्स क्या होते हैं, परम्यूटेशंस के मल्टीप्लिकेशन कैसे करते हैं, उसके साइकिल्स, डिसजॉइंट साइकिल्स, पेयर वाइज परम्यूटेशंस, ये सब पॉइंट्स हमने लास्ट एग्जांपल में क्लियर किए हैं। उसके ऊपर बहुत सारे एग्जांपल्स लिए हैं। तो आज इस वीडियो में हम कोसेट्स एंड देयर प्रॉपर्टीज देखने वाले हैं। लास्ट पॉइंट है इस चैप्टर का, मोस्ट इम्पोर्टेंट है। सो फर्स्ट डेफिनेशन देखते हैं, उसके बाद में एग्जांपल देखते हैं, उसके बाद में थ्योरम्स है, करोलरीज है। सब पॉइंट्स आज इस वीडियो में हम क्लियर करने वाले हैं। तो फर्स्ट हम कोसेट एंड देयर प्रॉपर्टीज देखते हैं क्या है। Cosets and their properties. Let G be a group and H is the subgroup of G. For the A belongs to G, the set HA equal to HA for every H belongs to H is called the right coset of H by an element set. So here A is exist here, so it is a right coset. And suppose if A is exist here, then it is a left coset. So इसमें कोसेट में दो पॉइंट्स है, एक राइट कोसेट है और दूसरा है लेफ्ट कोसेट। सो इफ एच के राइट बाजू में है तो उसको राइट कोसेट कहेंगे, इफ एच के लेफ्ट बाजू में है तो उसको हम लेफ्ट कोसेट कहेंगे। सो एच बी ए सब ग्रुप ऑफ जी, देन द नंबर ऑफ डिस्टिंक्ट राइट और लेफ्ट कोसेट ऑफ एच इन जी इज कॉल्ड द इंडेक्स ऑफ एच इन जी। सो एग्जाम्पल्स देखते हैं, उसके बाद में थ्योरम है, वो थ्योरम देखेंगे। सो फर्स्ट हम एग्जाम्पल देखते हैं। So examples, let Q is equals to 1 minus 1, I minus I, J minus J, K minus K. B, group of quaternions and H is equals to 1 minus 1, J minus J, B its subgroup. Find all right and left coset of H. So लेफ्ट एंड राइट दोनों निकालना है हमें। सो फर्स्ट वी हैव ओनली टू डिस्टिंक्ट लेफ्ट कोसेट ऑफ एच, that is 1h minus 1h, jh minus jh, and remaining ih minus ih, kh minus kh. These are the left coset. Then right coset of h, where ये 1h लिखा है, यहाँ पे हम h1 लिखेंगे, h minus 1, hj, h minus j, again hi, h minus I, hk, h minus k. सो ये हुए लेफ्ट कोसेट एंड राइट कोसेट। नेक्स्ट एग्जांपल देखते हैं। लेट G is equals to Z6 and H is equals to 0 bar, 3 bar. B, subgroup of G, find all right and left coset of H. So here values are Z6, H is equals to 0 bar and 3 bar दिया है. So Z6 is the additive group. Consider Z6 is the additive group. Then therefore, if suppose A belongs to H, then write coset of H. Write coset of H by G is written as H plus A, and similarly left coset of H by G is written H plus A H. So we have so first value will be 0 bar. So H are given 0 bar and 3 bar. So 0 bar plus 0 bar करेंगे, again 0 bar plus 3 bar plus 0 bar करेंगे, तो इसका आंसर आएगा 0 bar and 3 bar, which is equals to H. नेक्स्ट H plus 1 के लिए 0 bar plus 1 bar, अगेन 3 bar plus 1 bar, तो इसका आंसर आएगा 0 bar 4 bar. तो H plus 2 के लिए 0 bar plus 2 bar, 3 bar plus 2 bar, तो आंसर आएगा 2 bar plus 5 bar, sorry 2 bar and 5 bar. Similarly H for 3 के लिए 0 bar plus 3 bar and 3 bar plus 3 bar. So इसका आंसर आएगा 3 bar and 6 bar. 0 bar plus 4 bar and 3 bar plus 4 bar. So 4 bar and 7 bar. Sorry 7 bar. 7 bar के लिए आएगा मॉड्यूलो 6 से 1 bar. So H plus 5 के लिए 0 bar 5 bar. So यहाँ पे 6 है, तो 6 के लिए मॉड्यूलो 0 आएगा. अगेन 3 bar plus 5 bar. So इसका आंसर आएगा 5 bar and 2 bar. So ये हुए लेफ्ट कोसेट के लिए. So here we see that here 0 bar and 3 bar are equals to this. Again here 0 bar and 3 bar equals to this. That means H, which is equals to H plus 0 bar, again which is equals to H plus 3 bar. तो ये इक्वल है. नेक्स्ट 0 bar 4 bar के लिए देखो 0 bar 4 bar, हियर 1 bar है. 1 bar और 4 bar में देखो H plus 1 which is equals to H plus 4. नेक्स्ट इक्वल क्या है, ये H plus 2 which is equals to H plus 5. These are the right coset. Right coset. Similarly, plus 0 bar is equals to plus 3 bar H, plus 1 bar H which is equals to plus 4 bar H, and plus 2 bar H which is equals to plus 5RH. And these are the left coset. So इस टाइप के एग्जांपल्स पूछते हैं एग्जाम में, सिर्फ लेफ्ट कोसेट और राइट कोसेट निकालना है. सो इसके ऊपर अभी थ्योरम है, थ्योरम भी मोस्ट इम्पोर्टेंट है. कोसेट का थ्योरम, लेट G be a group and H be a subgroup of G. Prove that first, for A belongs to G, HA is equals to H, if and only if A belongs to H. B, for AB belongs to G, B belongs to HA, if and only if HB is equals to HE. C, there is one-to-one correspondence between any two right coset of H, that is HA is equals to HB for AB belongs to G. And last, any two right coset of H are either identical or disjoint. So one by one proof करेंगे. तो फर्स्ट क्या प्रूफ करना है हमें, फॉर ए जी इज द ग्रुप एंड एच इज द सब ग्रुप है. तो फर्स्ट फॉर ए बिलोंग्स टू जे, एच ए इक्वल टू एच इफ एंड ओनली ए बिलोंग्स टू एच. सपोज A belongs to G, then HA is equals to H. Here you have given A belongs to G and HA is equals to H, and therefore E is also belongs to H because H is a subgroup, and therefore E into A is also belongs to H and A belongs to H. ये प्रूफ. अगर कॉन्वर्सली प्रूफ करना हो तो let A belongs to H here, that means H is belongs to H. So HA which is belongs to H, since H is a subgroup, and therefore HA is a subset of H. तो इसको हम 1 कहेंगे. Now so A is belongs to H है. Now any B is belongs to H. Since A is belongs to H, since A belongs to H, that means B into A inverse, which is equals to H, which is also belongs to H. So B is equals to B into E is the any identical elements. So B, suppose E की जगह पे हमने A और A inverse डाला. यहाँ पे देखो B और A inverse है H, तो HA आ जाएंगे. तो HA is also belongs to this HE. That means H is a subset of HA. This is the second. Here देखो HA is a subset of H. H is a subset of H. And from 1 and 2, HA is equals to H. सो ये फर्स्ट पार्ट प्रूफ में। सेकंड प्रूफ करना है। सेकंड में क्या है? फॉर ए बी बिलोंग्स टू जी, बी बिलोंग्स टू एच ए, इफ एंड ओनली एच बी इक्वल टू एच ए। तो ये पार्ट हमें प्रूफ करना है। सो इफ B belongs to HA, then we have to show that HB is equals to HA। ये हमें प्रूफ करना है। So suppose X और Y हम कंसिडर करते हैं एलिमेंट्स। So first हम X लेंगे। X is belongs to suppose HB, so that X which is equals to क्या आएगा? H1B, और H1 is belongs to H, and therefore B is belongs to HA, then B is also equals to H2A। अगर X is belongs to HB है तो X के लिए वैल्यू होगी X1A, so B belongs to X है तो B के लिए वैल्यू होगी H2A, for H2 is also belongs to H, and thus X is equals to H1B है, so here B की वैल्यू हम डालेंगे H1 H2A, और this H1 और H2 will be considered as H, that means X is equals to HA, that means X is belongs to HA, for H1 H2 is equals to H which is belongs to H। so इसको हम फर्स्ट पार्ट। so ये हुआ X के लिए। नेक्स्ट सपोज कंसिडर लेट Y is belongs to HA, be any elements। here X is belongs to HB किया, अभी Y is belongs to HA किया, then Y is equals to क्या आएगा? H3A आएगा, for H3 is belongs to H, सेम ऊपर जो किया है वही। एंड सपोज B is equals to H2A, then A is equals to क्या आएगा? H2 इनवर्स B आ जाएगा। सो Y is equals to H3 और A की वैल्यू हम डालेंगे H2 इनवर्स B, so here H3 and H2 inverse into B, so these values will be also B, and therefore Y is equals to this H into B, and therefore HA is subset of HB, and from 1 and 2, HA is a subset of HB and HB is subset of HA, and therefore HA is equals to HB। So conversely, suppose HB is equals to HA है, conversely proof क्या करना है? B is belongs to HB and HB is equals to HA, so B is a subset of HA, hence proof। so C part क्या है? There is one-to-one correspondence between the any two right coset of H, and that means HA is equals to HB। ये हमें प्रूफ करना है। So consider let HA and HB be any two right coset of H। Define there is a one-to-one mapping here, therefore HA is one-to-one mappings to HB। Then sigma of HA which is equals to HB for HA is belongs to HA, and sigma is a one-to-one mapping. One-to-one mapping. Therefore, sigma of H1A which is equals to sigma of H2A. one-to-one मैपिंग है इसलिए सो H1A के लिए हम वैल्यू डालेंगे H1B और H2A के लिए वैल्यू डालेंगे H2B. हियर B भी कैंसिल करेंगे बाय कैंसिलेशन लॉस से. सो H1 इज इक्वल्स टू H2 आ जाएगा. सो H1A इज इक्वल्स टू H2A, and therefore there is one-to-one correspondence between any two right cosets of H. So लास्ट पार्ट थ्योरम का प्रूफ करेंगे हम. लास्ट पार्ट क्या है? Any two right coset of H are either identical or disjoints. So let HA and HB be any two right cosets of H. Be any two right coset of H. If HA is intersection of HB, then there is a value of 5. That means there is nothing to prove. Suppose HA intersection HB is not equals to 5. That is X is belongs to HA intersection HB. That means X is belongs to HA, X is belongs to HB, and therefore X is equals to H1A and X is equals to H2B. For H1, H2 is belongs to H, and here H1A is equals to H2B. That means A is equals to, here A is equals to H1, here आएगा तो इधर आ जाएगा तो H1 इनवर्स आ जाएगा तो H2B. here H1 इनवर्स A is equals to, इसकी जगह पे हम H डालेंगे और H is equals to H inverse H2, H1 inverse H2. And then HA is equals to H into, here HA is equals to H into H, A की जगह पे H भी डालेंगे. That means H, sorry, here capital H, small h into B. So H की जगह पे हम कैपिटल H डालेंगे. So here HA is equals to HB, where HH is equals to H, and therefore HA is equals to HB. These are identical or disjoints. Both are equal, that means these are identical. तो ये हुआ हमारा फर्स्ट थ्योरम, जो कि फर्स्ट थ्योरम में 4 पार्ट्स थे, बहुत इजी है. सो वन बाय वन हमने ये पार्ट्स प्रूफ किए हैं. सो नेक्स्ट थ्योरम देखते हैं. दैट मीन्स दिस थ्योरम विल बी द प्रॉपर्टीज ऑफ कोसेट्स है. Theorem 2. Properties of cosets. So first, A belongs to AH. B. AH is equals to BH if and only if A inverse B belongs to H. C. AH is equals to HA if and only if H is equals to AH A inverse. And D. AH is subgroup of G. तो ये प्रॉपर्टीज भी है और थ्योरम भी है इफ एंड ओनली इफ ए बिलोंग्स टू एच. वन बाय वन हम प्रूव करते हैं. तो A belongs to AHE. Since H is a subgroup, H is a subgroup of group G, and AB is belongs to G, and therefore AH is equals to AB for every H is belongs to H. It is a left coset. Is left coset of H in G because here is A. So first A, for A belongs to G, then A belongs to AE, which is also belongs to AH. So ये फर्स्ट पार्ट प्रूफ है. बी पार्ट के लिए हमें क्या प्रूफ करना है? AH is equals to BH if and only if A inverse B belongs to H. तो इसके लिए देखो क्या करना है हमें. So AH is equals to BH. So AH is equals to BH if AB belongs to G. Then H is equals to क्या आएगा? ये A इधर आएगा तो A inverse BH आ जाएगा. So H is equals to XH and X के लिए हमने क्या कंसिडर किया है? A inverse B. अगर X belongs to H है, X belongs to H आता है तो A inverse B is also belongs to H है. तो ये हुआ हमारा सेकंड पार्ट. सो थर्ड के लिए देखो AH is equals to HE if and only if H is equals to AH A inverse. So AH is equals to HA. So here हम post multiply करेंगे. Post multiplying by A inverse. So AH A inverse HA A inverse. So AH A inverse. So here A और A inverse की वैल्यू E आ जाएगी. That means AH A inverse which is equals to H आ जाएगा. Because HE is the identity is equals to H. So hence proof. So last D point है. That means AH is subgroup of G if A belongs to H. So if AH is subgroup of G, then it contains identity element E, and thus AH is the intersection of EH, which is null. not equals to none. But we have theorem any two left we have theorem but any two left coset are identical or disjoint, and therefore AH is the intersection of EH, which is not equals to null set. That means AH is equals to EH. So E is the identical. So therefore AH is equals to H. That means A belongs to H. So conversely, if A belongs to H, then AH is equals to EH. And therefore AH is equals to H. And AH is equals to H. H is a subgroup of G, which is subgroup of G. तो फिर से एक बार मैं थ्योरम आपको समझाती हूँ. यहाँ पे देखो A is belongs to AH है. Since H is a subgroup of G and therefore AB belongs to G, AH is equals to AB where H is belongs to H and is the left coset of H and G. For A is belongs to G, then A is equals to AE, which is also belongs to AH. तो फर्स्ट पार्ट ये प्रूफ हो. सेकंड के लिए क्या है, AH is equals to BH if and only if A inverse B belongs to H. So AH is equals to BH, AB belongs to G. So H is equals to क्या है, ये इधर है A, तो इस टाइप इधर आ जाएगा तो ये इनवर्स हो जाएगा, तो A इनवर्स BH है. एंड सपोज इसको हमने X कंसिडर किया तो X is belongs to H है, that means A inverse B is also belongs to H. थर्ड पार्ट है AH is equals to HM if and only if H is equals to AH A inverse. यहाँ पे हमने क्या किया है, दोनों साइड से हमने पोस्ट मल्टीप्लाई किया है A इनवर्स से. सो यहाँ पे AH A इनवर्स बिकॉज ये हमें प्रूव करना था इसलिए. सो इसकी वैल्यू E है. सो AH A inverse is H and hence the proof. Then last is the AH is the subgroup of G if A is belongs to H. ये प्रूफ करना है. तो if AH is a subgroup of G, then it contains the identity elements. So AH is intersection of EH, which is not equals to null set. But any two left cosets are identical or disjoints. So AH intersection EH is not equals to 5, then AH is equals to EH. These are identical, therefore it is equals. Therefore AH is equals to H, A is belongs to HK. And suppose if A is belongs to H है, then AH is equals to EH. AH is equals to H, which is a subgroup of G. So ये दो थ्योरम हमने देखे हैं. थर्ड थ्योरम देखेंगे हम, Lagranges theorem. Theorem number 3, Lagranges theorem. So theorem देखो क्या है, the order of every subgroup of a finite group divides the order of group. That means order of every subgroup, order of H divides order of group यानी कि G. ये हमें प्रूफ करना है. So Let G be a finite group and H be a subgroup. If H is equals to identical E or suppose G, then the result is obvious. That means it contains any identical elements. So suppose H is proper subgroup of G, proper subgroup of G, then order of G is equals to N and order of H is equals to M. So N is number of elements in G and M is number of elements in H. And since G is finite, G is a finite group, therefore there are finitely distinct right coset of H. Right coset of H. So finite, therefore there has limit. And right coset then यानी कि HA1, HA2 up to HAK. These are right coset of H in G. So for any X belongs to G, X belongs to HX. That means G belongs to right coset of H. And therefore, G is a subset of HA1 union HA2 union up to HAK. These are the union. Group is the subset of this union. And therefore, HA1 is a subset of G, HAI. For every I is equals to 1 to up to K. I consider किया 1 to up to K elements के लिए. That means HA1 is a subset of G. HA1 union HA2 union HAK, which is subset of G. Okay. Therefore, G is equals to HA1 union HA2 union up to HAK. So, and therefore, number of elements in HAI is equals to number of elements in H. And therefore, order of G, which is equals to K into order of H, because K elements. And therefore, order of H divides order of G. So, yay, subgroup is divides groups and hence the proof. That means the number of distinct right or left coset of H in G is equals to order of G divides order of H. And order of every subgroup of a finite group, it divides order of the groups. That means order of H divides order of G. So ये हुआ हमारा Lagranges theorem. इसके ऊपर जो corollary है वो हम 1 by 1 देखते हैं. सिंपल और छोटे छोटे corollaries हैं. So first corollary देखते हैं. Corollary number 1. So if G is a finite group, G is a finite group and A belongs to G, then order of A divides order of G. तो ये हमें प्रूफ करना है. So since G is finite group, and A belongs to G, therefore there exists a positive integer m such that A raised to m is equals to E, and where m is less than or equals to order of G. That means m is the any smallest integers. Now consider h is generated by A. So therefore A raised to m is equals to E, and then h is equals to क्या आएगा E a square up to a raised to m minus 1 because it is generated by A. Sorry, therefore order of h क्या आएगा m तक वैल्यू यानी कि m आ जाएगी. And by Lagrange's theorem, क्या था Lagrange's theorem? Order of h divides order of G, and therefore here order of h is m. M is what? A, and that means order of A divides order of G. Hence proof. ये फर्स्ट corollary. Second corollary, if G is a finite group and A belongs to G, then A raised to order of G, which is equals to E. So ऊपर के फर्स्ट थ्योरम में corollary क्या थी? ऑर्डर ऑफ A डिवाइड्स ऑर्डर ऑफ G. So यहाँ पे क्या दिया है? If G is a finite group and A belongs to G, then A raised to order of G is equals to E. So order of G, which is equals to K into order of A, and therefore A raised to order of A, which is equals to E. So we have A raised to order of G, which is equals to A raised to K into order of A. That means A raised to order of A raised to K, and this value will be E. So E raised to K, that means E, and therefore A raised to order of G, which is equals to E. So ये फर्स्ट सेकेंड corollary. नेक्स्ट थर्ड corollary है corollary 4, sorry, corollary 3. Fermat's theorem. If P is a prime number and A is any integer then A raised to P is congruent to A mod P. तो इसका प्रूफ देखो, ये फॉर्मेट्स थ्योरम है कॉन्ग्रुएंस में. So if P divides A, then A is congruent to 0 mod P. So divides का फॉर्मूला congruence में लिखा है, and hence 0 is congruent to A raised to P, which is congruent to A mod P. So if P divides A, so now if P not divides A, then GCD of PA, which is equals to 1. 1 Q, because P is the prime. इसलिए इसकी वैल्यू 1. And therefore A raised to phi of P, which is congruent to 1 mod P. So therefore A is raised to P minus 1, which is congruent to 1 mod P. अगर इसको हमने स्प्लिट किया A raised to P और A raised to minus 1, which is congruent to 1 mod P. So here A raised to minus 1 ही इधर आके वो ऊपर जाएगा, +1 हो जाएगा, mod P. So A raised to P is congruent to A mod P, and this is our Fermat's theorem. So last corollary, number 4. So corollary 4. If G is a finite group of prime order P, then G is cyclic group. So proof में देखो. If G is a finite group of a prime order P, then G is a cyclic group. तो ये हमें प्रूफ करना है. So H is equals to A, which is generated by A, be a cyclic group, cyclic subgroup of G, of G, and let A is not equals to E, then H is not equals to E. That means not identity. Then we have Lagrange's theorem. By Lagrange's theorem, order of H, which is equal, order of H divides order of G. That is, order of H divides P. P is a prime, and order of H, which is greater than 1, and P is prime. And therefore, order of H, which is equals to P, H is equals to G. P is the prime and prime, and G is the cyclic group, and therefore H is equals to G, and so that G is cyclic group generated by A. So ये corollaries है लैग्रांजेस थ्योरम्स के ऊपर जो ये करोलरीज थे हमने प्रूव किए हैं, 4 करोलरीज हैं। तो ये इस वीडियो का लास्ट पॉइंट था, जिसमें टोटल थ्योरम्स थे, और ये थ्योरम्स एग्जाम में पूछते हैं। प्रॉपर्टीज ऑफ कोसेट, कोसेट देखे हैं हमने, कोसेट्स के प्रॉपर्टीज देखे हैं। लैग्रांजेस थ्योरम्स देखा है, लैग्रांजेस थ्योरम्स में 4 करोलरीज देखे थे हमने, उसका प्रूफ भी देखा है हमने। तो इसमें से कोई भी एग्जाम में पूछते हैं, तो बहुत इजी है। अभी इस वीडियो को मैं स्टॉप करती हूँ। अगर आपको ये वीडियो अच्छी लगे तो आप लाइक करें, शेयर करें और सब्सक्राइब करें। थैंक यू। नहीं। हेलो।